let's be real for a second. Have you ever started a brand new PHP project and it's beautiful, it's clean, and then 6 months later you're terrified to even touch it? We have all been there. Today, we are going to talk about the way out of that mess. We're diving into design patterns, the proven blueprints for writing PHP that's actually scalable, maintainable, and, dare I say, a joy to work with?
You know, every project kicks off with so much promise. It's that honeymoon phase. Your classes are perfectly focused, your logic is crystal clear. This user class right here, it does one thing, and it does it really, really well. It's just a beautiful, simple start.
But then reality hits. The feature requests start piling up, the deadlines get tighter, and before you know it, you're not looking at clean code anymore. You're staring at what we call a big ball of mud. Everything is tangled up with everything else. You change one tiny thing over here, and suddenly 3 other things you didn't even know were connected just break. It's a total nightmare to maintain.
So that's the million-dollar question, isn't it? How do we break this cycle? How do we build our applications from day one so that they can grow and change without collapsing into a chaotic mess?
Well, the answer is actually pretty simple. You use a blueprint. And in the world of software, we call these blueprints design patterns. And listen, they're not some kind of dark magic or silver bullet. They're just really, really good ideas that smart people have figured out and tested over the years. And here's the most important takeaway. The problems you're facing, you are not the first person to face them, not by a long shot. Design patterns are these battle-tested solutions that the entire programming community has been refining for decades. They're like general recipes you can adapt to solve your own specific problems.
It's also really important to know what design patterns aren't. You can't just download a pattern like you download a library and plug it in. They're concepts, not code. And they often prioritize things like clarity and long-term maintainability over raw nanosecond performance. And please, don't just go refactoring your code for the sake of using a pattern. They're a tool to solve a problem, not the end goal itself.
Okay, now that we know what these things are, let's get our hands dirty. We're going to start with one of the most fundamental tasks in any app, creating objects. Creational patterns give us smart, flexible ways to do this, so our main code doesn't have to worry about the messy details.
First up, we've got the factory pattern. I want you to think of this like a specialized workshop just for building your objects. You just walk up to the factory and say, hey, I need one of these, and it handles all the complicated construction behind the scenes. This is awesome because it separates your main code from the specific classes it needs. For example, picture an e-commerce site. Instead of having new book, new clothing, and new toy sprinkled all through your code, you just make one call, product factory create book. Now, if you need to change how a book is made, maybe add a new dependency, you only change it in one place, the factory. Super clean, super centralized.
All right, next up is a really famous one, and maybe a little controversial. The singleton. Its job is incredibly simple, but powerful. It makes absolutely sure that a class has one and only one instance for the entire time your application is running.
And the textbook example here is your database connection. Think about it. You definitely don't want to be opening a new connection to the database every single time you run a query. That would be crazy inefficient. A singleton makes sure that every single part of your application shares the exact same connection instance. But here's a word of warning. Singletons can be tricky. They can create this global state that makes your code really hard to understand and even harder to test. A more modern and, frankly, more flexible way to handle this is something called dependency injection. So instead of a class reaching out and grabbing its own database connection, that connection is handed to it, or injected, from the outside. This makes your classes way more flexible and, this is the big one, so much easier to test.
Okay, so we've made our objects in a smart way. Now what? How do we make them talk to each other without creating that tangled spiderweb of code we're trying to avoid? Let's check out some patterns that are all about managing those relationships. So let's imagine a real-world scenario. A user on your social media app posts a new photo. How in the world do you update the feeds for all of their followers at the same time? You definitely don't want your user object to have a hard-coded list of every single follower. That would be a tangled mess.
The elegant solution to this is the observer pattern. It sets up this kind of one-to-many relationship. The main object, we'll call it the subject, doesn't actually know anything specific about its observers. It just knows it has a list of things that need to be poked whenever something important happens.
Here's how it breaks down. Step 1. The user's feed is our subject, and it keeps a list of its observers, the followers' feeds.
Step 2, the user posts something new, which changes the state of the subject. Step 3, the subject just loops through its list and shouts "notify" at every observer. And Step 4, each follower's feed hears that notification and runs its own update method to grab the new content. It's a beautifully simple and decoupled system.
Okay, let's talk about another powerhouse pattern for taming complexity, the repository pattern. What this does is it builds a clean wall, an abstraction layer, right between your app's core business logic and all the nitty-gritty details of how you're storing and fetching data.
So why should you care about this? Well, first, your business logic no longer cares if you're using MySQL or Mongo or a text file. It just asks the repository for a user. That separation is huge. Second, it makes testing a walk in the park because you can just swap out the real repository with a fake one. And third, you can reuse queries all over the place like a find publish post method without ever duplicating your database code.
And now for the big reveal. You might be listening to all of this and thinking it sounds kind of academic or abstract, but I've got news for you. If you have ever used a modern PHP framework, you've been using these patterns the entire time, maybe without even knowing it.
Just take a look at a framework like Laravel. You know how it encourages you to split your logic into controllers and services? That's the single responsibility principle, and it's what makes the repository pattern work so well. How about Laravel's middleware system, where you can add new functionality without touching the core code? Pure open-close principle. And that magical service container that handles all your dependencies? That is the dependency inversion principle in action, making dependency injection a breeze. These patterns aren't just theory, they're the bedrock of modern frameworks.
So I want to leave you with a question to take back to your own code. Think about your current project. Think about that one controller that's gotten way too big or that complicated function that everyone's afraid to touch. What tangled part of your project right now could be cleaned up and made stronger by applying one of these powerful, time-tested design patterns?